Hello, and welcome to our 401 project, Architecture by Enzymes. I am Sam Gibbs.
And I am Luke McDonald. Situated in the context of a global pandemic and environmental crisis, we identified concrete as an intersection. Concrete, contributed through new construction, is one of the worst environmental culprits. It pollutes air, emits CO2, damages ecosystems, fills landfills, and causes flooding. We challenge apocalyptic notions of urban growth and disasters and instead propose the idea of making with the city in an act of reassembly. The existing concrete and the future production of concrete must be questioned, and the pandemic may provide a beginning for one of these opportunities. The pandemic has at times shut down cities all around the world, consequently leaving streets as vacant stretches of concrete, forcing us to question their necessity.
Thinking of these ideas in the context of Des Moines and the Midwest as a whole, we focus on issues of flooding. Due to the larger environmental crisis, extreme disastrous floods continue to occur at alarming rates. Flooding, like the pandemic, affects neighborhoods at disproportionate scales, and these crises must not be isolated, but instead viewed as assemblages. Rather than provide solutions of prevention, we assist in reconfiguring the materiality of the city through the transformation of the abundant concrete. We propose a speculative future where streets and highways become irrelevant to the future of transportation and instead become the materiality of the future. Those areas once rendered sterile through concrete and asphalt become new spaces for the reimagination of public spaces.
The site has a historical train depot and is situated within Des Moines' East Village. The city currently has plans to transform the remains of the adjacent decommissioned railroad into a bike path, but we propose to utilize the rail as a means of transportation for robots and materials with the future opportunity for transporting passenger cars.
Current problems faced in the decomposition process of concrete are limited by the ability of various bacteria and enzymes to break down matter. Therefore, we speculate a process that involves both robots and enzymes as a single ecology that facilitates a decomposition process. The selection of robots, deconstruction robots, freight cars, conveyor belts, and micro robots allow us to reconsider the program and design spaces of various scales. Given the robots will operate outside of the physical site boundaries, we must consider the program to extend beyond the site and blur with the assemblages of the city. In the case of our project, robots work in the dirty and dangerous, moving between tiny voids of rubble.
The depaving of roads begins with the use of demolition robots. Once deconstructed, an autonomous cargo freight car moves the depaved concrete along the nearest rail, ultimately delivering it to our site. Once arriving at the site, the material is transferred from the freight cars to a conveyor belt that drops the concrete into the composting pit. There, micro-robots live within the voids of the rubble, and they begin to drill, cut, break, and apply bacteria and enzymes that expedite the decomposition process. Within the depot, growing root structures will later be integrated into the decomposed concrete. This new assemblage can be relocated to floodplains in an effort to resist erosion. At these erosion sites, the concrete will act as an anchor for this new root structure to grow and intertwine with the ground, forming yet again a new reassemblage. This decomposition process accepts the idea that the concrete does not turn into this organic matter, but is rather an imperfect assemblage. The deconstructed and decomposed concrete is a versatile material. It can be used in gabion and aggregate cast walls, permeable paving, and general landscaping.
In addressing building materiality, we chose to go with the counterintuitive option of concrete, but chose to do so in a way that emphasizes the interaction with the landscape. The concrete is designed to be cast around large recycled pieces of aggregate from depaved concrete slabs, ultimately reducing the required new material. Building within underground depths allow for reducing the impervious surfaces found in above-ground buildings. With this use of concrete, the building itself could be decomposed through the same process it houses, where the remains will be a site with the newly integrated matter into the landscape. We chose analog methods to represent the imprecise, the messy, and the ugly nature of making.
Our building composition allows for the use of a concrete casting method, where the earth can be used as the formwork for casting 3 different vaulted typologies. The process starts with the use of automated construction robots that begin to extract the ground. As these larger robots move closer to the moments of casting, smaller robots will sculpt the form before the concrete is casted. This process then repeats as the earth is filled back to ground level, and the extra dirt will then be redistributed within the landscaping of the site.
To understand the potential issues of the construction process, we decided to experiment with these ground casting methods. We began with digging a hole to a depth where we found more malleable dirt, then through carving and reforming, we created our molds. The concrete was then cast, cured, and in this case removed from the soil, revealing textures and unanticipated nuances of form.
In considering programming, we looked beyond the scope of the walls and requirements of the project and recognized the environmental factors as programs themselves rather than applied conditions. Within our design, this can be seen through the composting pit that requires a very specific environment to stimulate the decomposition process.
In the entrance sequence through the lobby, there is a space for an experimental pavilion and an outdoor gathering space. In staying consistent with the idea of impermeable surfaces, we are utilizing wood slats for ramps and permeable pavers on stretches of flat circulation. The interior lobby is a series of vaulting columns that incorporate two passive strategies where light is allowed through vertical slits and rainwater can be collected and stored underneath the lobby within the cistern. Our auditorium is a space dedicated to educational programs that mainly consist of lectures, conferences, and demonstrations. The lobby, auditorium, and cafe are interconnected with a ramp that joins the public to the main entrance and the central stair tower. The private research labs located a floor below the public entities follow a single ramp around the perimeter of a pit. The main focus of these labs is producing and researching new bacteria and enzymes for different materials such as asphalt and plastic. Each research lab has a thickened wall that acts as a barrier between the two drastically different climate conditions. Researchers place the bacteria for the robots to come and collect before redistributing and applying the bacteria to the concrete. This thickened wall acts as a point of exchange and creates symbiosis between human and non-human.
Questioning the existence, purpose, and futures of roads is situated not in a single idea, but instead in the intersection of a global pandemic on top of an environmental crisis. A future without roads is not one without concrete, but instead one with concrete in different places and in new assemblages.